Okay, this one's more realistic. If we have a speed, if we have a speed that is crazy fast relative to the speed of light, like approaching the speed of light, then we're going to get a gamma that is noticeable, that will actually have some impact. Our equation for gamma is gamma equals 1 over 1 minus v squared over c squared, and all of that is under its own square root. Again, because I'm going to do a bunch of math in my head, I'm going to write it this way, 1 minus v over c all squared, and then that's under the square root sign. For this one, we'll start with the speed and then we'll deal with the length after the fact. Our gamma is going to be 1 over 1 minus 1 times 10 to the 8 over 3 times 10 to the 8. That fraction has to be squared, and then that 1 minus is all under the square root. I like writing it this way with the square on the denominator that way because I can do a bit of canceling. The 10 to the 8 here cancels with the 10 to the 8 there. So really what I've got is gamma equals 1 over 1 minus 1 over 3 squared. 1 over 3 squared, I can do that in my head. That's 1 over 9. All of that is under the square root sign. I can still do a little bit of math in my head. 1 minus 1 over 9 is 8 over 9. All that is under the square root sign. I've got a fraction on the denominator of a fraction, so I can flip things around. That's the same as the square root of 9 over 8. At some point, we're going to jump in and do some calculator work. We could go a little bit farther. Root 9 over 8 is the same as root 9, which is 3 over root 8. We could maybe simplify that root 8. It's 2 times 4, so it's 2 root 2 or something like that. But we might as well calculate it here. We can carry extra decimals, but roughly 1.06 is the value of gamma. So for spaceship zooming, for anything zooming at 1 times 10 to the 8, so 1/3 the speed of light, we get a gamma of only 1.06. That means time is going to tick slower by a factor of 1.06. The mass, the spaceship is going to behave as if it's 1.06 times heavier. It's not heavier, just it takes more force, so we interpret that as an increase in mass. The way this question is worded, what it also means is that the length is going to appear 1.06 times shorter. So if we take the given 30 meters and divide by 1.06, that gives us how it's going to appear. When I crank it out on my calculator within rounding, I get 28.28 meters. That's how special relativity kind of works. From a speed, we can find the gamma, and from the gamma, we can apply it. In this case, I gave you a length. We know that the spaceship is going to look shorter, so we're going to divide the given length by the gamma that we calculated.